the one from the previous week, last week and week before? No problem.
I haven't actually looked at the one from last week, but in the past they've been fine.
Okay, good. Okay, let me just do this. Okay, now it's coming. Okay, cool. Got it. Okay. So, yeah, so this is week number 10. So we're going to look at chapter 10 from the textbook, and it's analyzing quantitative data. So let me share my screen with you. Where's my screen? Yeah, okay. Oh, sorry, it's a bit, okay. I have to show that first and then share the screen. Oh, okay. Where is it coming? Oh, all right. Minimize this and share the screen. Hopefully it works now. Descriptive. Can you see it, Messi? All good? Okay, cool. All right, so let me just grab that. Yeah. So, almost done. We are almost the end of the semester. One more next week, I think. And then we ready for the last assignment and then final exams. Yeah. So this is chapter 10, analyzing quantitative data. We'll look at the qual last time. So we're going to look at quant today. And then next week, we're going to look at the output, basically the result of your final report and what it looks like, what it should consist of. Okay, so today we're going to look at coding and data entry. We did this already in our workshop. If you remember back then when we input the data, we put the coding. So we're going to look at again as a whole process as part of the quantitative analysis. Then we look at tabulation and descriptive. Again, we also did that in our workshop. Remember, we did the crosstab, and then we did the descriptive statistics. So we're going to just go back and make sure that we understand all the statistical terms used for quantitative analysis. And then we look at statistical significance and hypothesis testing. And you all probably remember when we're trying to test the hypothesis, it's important for us to understand the basic understanding when we say we're testing null hypothesis. And the null hypothesis is pretty much all the time is there is no correlation or there is no association or there is no relationship between variable 1 and variable 2. Okay, and then the alternative one would be there is. So your aim is basically to reject the null hypothesis. And one easy thing to remember is when the test is significant, which is the probability value is less than 0.05, you can say that the test is significant, then you can reject the null hypothesis. So that means there is a relationship or association or correlation. Okay, and then we look at relationship between variable in terms of correlation and also regression, in which you have one dependent variable and more than two independent variable. Okay, so those are basically what we're going to look on today's seminar. We know that once data collection has been completed and the validation and the editing described in chapter 8 has been undertaken, then the researchers will move on to the stage of data entry and analysis. And this chapter, second last chapter, is designed to introduce you to the three main steps involved in this phase of the research process. And they are coding, data entry, and tabulation, and statistical analysis. Okay, So far, if you remember, we did the basic descriptive, and then we did the simple t-tests, and then we did independent sample t-tests, in which we compare two groups, either male or female, or any group really. Like you can think about business, non-business, or metropolitan versus non-metropolitan or regional. So that two groups that you compare. For the mean, you use independent sample t-tests. And then we'll look at ANOVA, or analysis of variance, in which we compare more than two groups. Remember, we look at our workshop, we have different income level and the likelihood to patronize the restaurant. Why did we use ANOVA? Because we have more than two groups of income. And then we look at education, for example. We have more than two groups of level of education. So that's independent sample t-test. And then we look at the cross-tab, cross-tabulation, in which we compare two nominal variable. Okay, yes, no. And then we look at the specific variable which asks question like, what time do you normally watch the TV ad or TV program? And then you have 1, 2, 3, 4, 5, 6, and then whether you are a patron of the restaurant. That's where you use association. And then we look at the correlation. Yeah, correlation is when you try to look at two different variables, like preference of tuxedo, waiter wearing tuxedo, remember, and also preference of unusual entry, remember. So we look at those two variables. So the correlation, that can be positive or negative. If the relationship is positive, that means if one variable increase or goes up, the other one also goes up. If one variable decreases, the other one also decreases. That's what positive relationship is. If it is negative, that means if one variable increase, the other one decrease. That's what negative means. If one decrease, the other one goes up. It's like seesaw. Okay, so that's the correlation. So cross association, correlation, and then we look at the what's the other one? The other one was the regression. Regression, when you look at one dependent variable, okay, we look at the likely, and then we look at factors or all the independent variable that we think may influence the likelihood. Okay, so we run that regression, and we ended up with I think 3 models, and then we pick the best one based on the coefficient of determinant or goodness of fit, or R square. Okay. Okay, and then this week we look at reliability analysis, which you all have learned, and hopefully you can apply all of them in your final assignment. Okay, so try to use as much as possible the thing that you have learned from this 10 workshop on SPSS, and pick each one of them and use the data that you have been given. You can look at the questionnaire, so you know information that you're collecting, what kind of information, by looking at the questionnaire, and you can apply that data set into different statistical technique that you have learned so far. Okay, so more and more component of these 3 steps, coding, data entry, and tabulation and statistical analysis, are undertaken automatically by computers now. You actually undertaken by computer through questionnaire, question analysis, or statistical software like SPSS. However, researchers need to develop an awareness and understanding of this activity and statistical technique if they are to both understand the data and present the findings in an accurate and confident manner. So this chapter really aims to provide that awareness and that understanding. Okay. So coding, let's look at the first one, coding. What is coding? I think coding is basically the first step, okay? The first step, and coding involves translating responses into a form that is ready for analysis. So to understand coding, it is important to understand how research responses are held in a computer file. Okay. So a computer file consists of all the responses relating to all the respondents in a study. So it is made up of a series of records, with each record containing all of the responses from one respondent. And each record is organized in the form of a number of fields, with each field representing a question in the questionnaire. So you can check that on your SPSS, where you look at variable and data. And codes are numerical data in each field representing the respondent answer to a particular question. And you can see in example 10.1 in the textbook as well. It's a computer file relating to our respondent answering a questionnaire consisting of 5 questions, for example. So we can say that coding involves the assigning of numerical codes to responses so that they can be, 1, recognized by the computer, number 2, stored in the data fields, and number 3, can be interpreted and also manipulated for statistical and tabular purposes. Okay. Data entry. What about data entry? Well, we can tell from by the name. With computer-assisted interviewing and web-based survey, data entry is basically done automatically. In all other situations, data have to be transferred from the questionnaire, either by an operator typing the responses from the questionnaire into the computer, or the optical scanning of questionnaire can be done using appropriate scanning equipment and questionnaire that have an appropriate layout. Okay. So remember, after you have entered the data, what's the next step? We call data cleaning. Okay, that's where you have to fix the data, making sure that all the missing data are not there, and if they have missing data, that you have a way to solve that problem with missing data. Okay. So that's data entry, or that's a coding. Okay, and data entry. What about the type of data? Okay, when we look at the data entry, okay, let's look at data entry. Okay, then we have different type of data. First one is nominal data. I think you've seen this already in your SPSS data that all the workshop we did during the week. Nominal data, when we talk about nominal data, the word nominal means name-like. In other words, the number assigned to object or phenomena that name or classify but have no true numeric meaning. So they're simply labeled or identification number. As you can see, when you try to say define gender, you have male and female. So 1 for male, 2 for female, or the other way around. It doesn't really matter. That's what we call nominal. Or you can use another example, type of transport use. 1 car, 2 coach, 3 train, 4 bicycle. Okay, that's nominal. Okay. Second one is ordinal. Ordinal data. Ordinal data stem from ordinal scales and have the labeling characteristic of nominal data, but also have the ability to communicate the order of the data. Okay. The numbers do not indicate absolute quantity, nor do they imply that the interval between the numbers are equal. So they don't imply that. So ordinal scales, for example, are used strictly to indicate the rank order. So the numbers are void of any meaning other than order. Okay. So good example, you can look at example in the textbook as well. Example 10.3. They said, please rank the following car makes from 1 to 5. So you have Ford, Renault, Fiat, BMW, Toyota, and try to rank them from 1 to 5, with 1 being the make that offer the best value for money, and 5 being one that offer the least value for money. Okay, so 1 to 5, and it works a little bit awkward. So 1 make the best value, and then 5 the least. So if Fiat, for example, rank 4 and BMW is 5, there is no indication as to whether Fiat much better or any slight better value for money than BMW, because it is your own preference, right? Okay. The other one is interval. These are similar to ordinal, with the added dimension that the interval between the value on a scale are equal. And that is not the case for ordinal. Okay, the interval, we assume that it is equal. So this means that when using a scale of 1 to 5, the difference between 1 and 2 is the same as the difference between 4 to 5, or 4 and 5. Okay. However, in an interval scale, the 0 point is not fixed. Instead, it is an arbitrary point. Okay, so you can use an example again. Please rate the following car makes on a scale of 1 to 5, where 1 represents very poor value of money and 5 represents very good value for money. Okay, so you can have Ford and 1, 2, 3, 4, 5. You can have BMW 1, 2, 3, 4, 5. You can have Toyota 1, 2, 3, 4, 5. So you assume that the scale between 1 to 2, 2 to 3, 3 to 4, 4 to 5, they're all equal. So that's the difference between interval and ordinal. So unlike nominal and ordinal data, arithmetic means that the standard deviation can be calculated using interval data. Correlation coefficient and many statistical tests, including t-tests, can also be used with interval data. Okay, the last one is ratio data. This consists of actual real numbers that have a meaningful absolute zero or origin. Okay, so actual characteristic of a respondent or situation such as age, height, level of expenditure, number of product purchased, and times taken are all examples of rapid scale variable. Okay, so that's the difference between all these type of data. The next thing we're going to look at is tabulation and statistical analysis. Frequency distribution. Researchers very often attempt to get a first feel of the data they have by producing a frequency distribution. So this is the first thing I would do probably for your assignment, your last assignment. I would do frequency distribution, so you can get your first feel about the data, which this will communicate the number of respondents who gave each possible answer to each question. Okay, so you can find out about how many male, how many female, all the basic statistic that you can get out of this frequency distribution. Okay. Cross tabulation. That's another example of basic statistical analysis. Cross-tab are both simple to use and also provide very powerful analysis technique. They examine the responses to one question relative to the responses to one or more other question. Okay, so you can, for example, you can look at maybe male, female, and car preferences. Okay, so car preferences, you can have all different car, and then you have gender, male and female. So this is a good example of how you can use crosstab in the analysis. Again, you can look at example 10.6 in the textbook, in which you can try to understand more about this crosstab. Descriptive statistic. This descriptive statistic helps to summarize the characteristic of large set of data using only a few numbers. Okay, so the most commonly used descriptive statistic are measure of central tendency. Okay, that include mean, mode, median, and measure of dispersion or range, interquartile range, and standard deviation. Okay, so what do you mean by measure of central tendency? Measure of central tendency indicate a typical value for a set of data by computing the mean, mode, or median. What's the mean? Mean is probably the most commonly used average in marketing research. So it is the arithmetic average and is calculated by summing all of the value in a set of data and dividing by the number of cases. So it can only be computed from interval or ratio metric data. The mode, as you all know, the mode can be computed by with any type of data, nominal, ordinal, interval, and even ratio, and represent the value in a set of data that occurs most frequently. However, there is one problem, and that is that any data may have more than one mode. That is the number of category value may all be equal and each share the highest frequency. And then the median. The median can be computed for all type of data except nominal data. Okay, so when all of the value in the data set are put in ascending or descending order, the median is the value of the middle case in series if the number of value is an even number, and therefore no single middle value exists. Okay, and the two middle value are added together and divided by 2. Okay, so the median has many cases on the higher side as on the lower side. So the measure offers the advantage of being unaffected by extreme cases at one and or other of data set. For example, it may be appropriate where a few extreme value may impact adversely on representativeness of the arithmetic mean. Okay, you can have a look at example 10.7, where you can look at the mean, median, and mode. Statistical significant, it's important to understand this concept. Yeah, significant is where the difference between two statistical measures is large enough to be unlikely to have occurred due to chance or sampling error. So if you want to think about this statistical significant in a relatively simple way, is when you can see the difference between null hypothesis and alternative hypothesis. So when it is significant, that means you have enough statistical evidence to reject your null hypothesis, which means that there is a correlation or there is a association or relationship between the two variables. Okay, so that will lead us to the hypothesis testing. So when you look at hypothesis testing, as I have mentioned many times, you always have, normally you have null hypothesis and alternative hypothesis. So if the test is significant, if you're using simple correlation or if you're using crosstab, you know how to look, right? Look at the probability and the significant level, sometimes it's called, and look at whether it is less than 0.05, less than 5%. If it is, then you can say that that test is significant. If that test is significant, then that means you can reject the null hypothesis. If you reject the null hypothesis, then you can explain what that alternative hypothesis means. Okay. All right. Measuring relationship. Then we look at the regression in the quantitative analysis. Regression is when you try to identify the relationship between one dependent variable. So this is called dependent because this variable depends on the independent variable. The independent, if you have just one independent, that's simple regression. But if you have more than one, okay, 2 or 3 or 4 or 5, in this case, we did that in our regression workshop, SPSS workshop, then we call it multiple linear regression. Okay. Then we also have correlation. With the correlation, we don't really know which one affects which, because all we know is between the two variables. This one goes up, the other one goes down, or the other one goes up, the other one goes up. That's all we know about correlation. Correlation uses an index to describe the strength of a relationship. So between 0 and 1. Okay, so how strong the relationship is, you can look at that correlation between 0 and 1. Sometimes it is good for you before you undertake the analysis, correlation or regression. It's good to have this scatter diagram so that you can see, in this case, we'll look at the regression where you have y as your dependent variable and x is your independent variable. So you just plot all the data for your x and y, in this case, just 2 dimensions. And then if you plot that, you can see this scatter diagram. Okay, if it's scattered that way, you can say it's positively skew, not skew, but it's positively a slope. The other one is negatively sloped, and then it's curved. And D is basically it's everywhere. You can't really tell the direction of this scatter diagram. Okay, so by looking at this, we're going to move on to multivariate data analysis. What is multivariate data analysis? Multivariate data analysis is the next one. Multivariate data analysis is basically the term for statistical procedure that simultaneously analyze 2 or more variables on a sample of objects. Okay, so for example, multivariate data analysis would enable the researchers to examine the relationship between advertising expenditure and number of salespeople, okay, and packaging costs and level of sales. So increased computer power has made it possible to examine complex relationship between multiple items with relative ease. The most common technique provided by statistical software packages and used by marketing researchers are multiple linear regression, multiple discriminant analysis, factor analysis, cluster analysis, perceptual mapping, conjoint analysis. I'll strongly encourage you to have a look at each one of them on the textbook, have a read and understand yourself. We don't have time to go through that, but as you can see there, multiple regression analysis, we did that in our workshop. So it's worth looking at that. And the rest, you can actually later on, if you want to use that, you can always go and visit and then try to understand that technique or statistical procedure. Maybe very briefly, I can tell you what it is. With multiple regression analysis, you already know that we are actually predicting what's going to happen to our dependent variable if we change our independent variable. So that's basically multiple regression analysis. It will enable researchers both understand the relationship between 2 or 3 more independent variables, and also to calculate the impact of independent variable on dependent variable. Multiple discriminant analysis is generally used to classify individuals into one of 2 or more segments or population on the basis of a set of measurement. Okay, so for example, with multiple discriminant analysis, the grouping may relate to brand usage, with respondent being either users or non-user of brand. So multiple discriminant analysis enables a researcher to predict the likelihood of a person being a brand user based on 2 or more independent variables, okay, such as size of weekly shop, income level, age, or purchasing level of related product. So you can see that this may allow the researchers to establish a model for classifying individuals into groups or into segments on the basis of the value of their independent variable. This technique, multiple discriminant analysis, can also be used to identify which variable contribute to making the classification. So overall, the objective in discriminant analysis is to find a linear combination of the independent variable that maximizes the difference between groupings and minimize the probability of misclassifying individuals or objects into their respective group. Okay, so that is multiple discriminant analysis. What about cluster analysis or factor analysis? Factor analysis is a procedure that study the interrelationship among variables for the purpose of simplifying data. And it can reduce a large set of variables or to a smaller set of composite variables or composite factors by identifying the underlying dimension of the data. Good example would be measure of size and value in a study may be indicator of the same theoretical construct. Okay, what are the reasons for performing factor analysis? Some of the reasons include it can provide insight from the groupings of variables that emerge, and this insight might have practical or technical significance. The other reason is it can reduce the number of questions or items and scales or attribute being analyzed to a more manageable number. Okay, so it reduces the number of items. So in marketing research, factor analysis is most frequently used when analyzing data coming from rating scales. Respondent may be asked to rate a service on a whole range of attributes. Within this, satisfaction with the service employee may be measured through a range of attributes such as product knowledge, empathy with the customer, speed of service, clarity of communication, etc. So researchers may want to add some of these attributes together to develop a composite score or to compute an average score for the concept. Okay, so factor analysis will determine whether and how attribute can be combined into summary factors such as interpersonal skill and technical ability. Okay, so we can say that a factor is thus a variable or construct that is not directly observable, but needs to be inferred from the input variable. Okay. Next one is cluster analysis. Cluster analysis refers to statistical procedure used to classify objects or even classify people into mutually exclusive and exhaustive groups on the basis of 2 or more classification variables. Now, frequently, marketing managers need to identify consumer segment so that marketing strategy can be developed and can be tailored to each segment. Okay, such segment can be based on, you can think of lifestyle, based on purchasing behavior, based on socio-economic characteristic, and so on. Okay, although a number of different approaches and procedures are available for clustering, the underlying process involves determining the similarity among people or objects with regard to the variable being used for clustering. Okay. You can look at example 10.6, in which they put the figure between the importance of protection against tooth decay and the importance of price. And they come up with 3 different clusters. Cluster 1 is where they include those people who purchase toothpaste on the basis of protection against tooth decay, tooth decay, and pay little attention to price. So that's the first cluster. Second cluster includes those people who purchase toothpaste on the basis of price and pay little attention to protection against tooth decay. And then finally, number 3 cluster. This cluster includes those people who do not pay attention to either price or even tooth protection. So they may be influenced by brand name, by taste, by appearance, type of dispenser, etc. So further scatter diagram would be required to determine this. Okay, so that's the benefit of cluster analysis, as you can see. Perceptual mapping, the next one. Multi-dimensional scaling, or perceptual mapping, or MDS, multi-dimensional scaling, involve perceptual mapping, which is the positioning of objective in a perceptual space. So this is particularly important in determining the positioning of brands relative to their competitors. Okay, so for example, toothpaste manufacturers may want to assess the position of their branded product against those of the competition in terms of protection, in terms of price, in terms of taste, in terms of modernity, freshness of breath, and level of whiteness. So respondent will be asked to evaluate each brand on this attribute, and the output from the data analysis is called a perceptual map. Okay, so this map is usually 2-dimensional, although 3-dimensional maps are also possible, and they are often more difficult to interpret. So where more than 2 dimensions are required, a series of 2-dimensional map is generally used, as you can see in example 10.7. So that's perceptual mapping. Conjoint analysis, also another common one. This analysis provides a quantitative measure of the relative importance of one attribute over another. It is frequently used by marketers to determine what features a new product or new service should have, and also how products should be priced. This is often used instead of the more expensive approach of qualitative research used in full concept testing. Okay, so in assessing the importance placed on attribute by consumer, it is rare to find that only one attribute is important, very rare. So people will buy their toothpaste on the basis of a combination of factors, usually. So they can look at price, combination of protection against tooth decay, flavor, size of packet, rather than on the basis of just one factor, like flavor only. Okay, so in conjoint analysis, the respondent is asked to make trade-off between the different attributes. Which attribute can be sacrificed? That's the question you need to ask. And at what level of price does protection becomes less attractive? Sometimes the preferences may be in conflict, For example, high protection against tooth decay for a very low price. The aim basically is to find some form of compromise solution, as you can see in, I think, table 10.18. So trade-off data are collected in one of two ways. Respondents are either asked to consider two attributes at a time or to assess a full profile of attribute at once. Okay, so that's conjoint analysis. So I already explained that, perceptual mapping and conjoint analysis. So I think that would probably be the last one for this seminar. So in summary, I can say that this chapter has attempted to introduce you to the key steps and most common approaches used by researchers when analyzing quantitative data. And these three main steps involve coding, data entry, tabulation, and statistical analysis. Okay, so coding is the transforming of responses into a form that is ready for analysis. Data entry, entering of the data into a computer, either automatically or manually. Crosstab and statistical analysis, the interpretation and communication of the meaning behind the data. So quantitative data exists in one of four forms. Can have nominal, can have ordinal, interval, and ratio. So the nature of each of these will impact on the type of tabulation and the type of statistical analysis that are possible. Okay, so it's important that you pay attention on this. The main form of statistical analysis can be categorized into one, descriptive statistic. So that's the measure of central tendency or measure of dispersion. Second one, statistical significance and hypothesis testing. So you can look at the t-test, independent sample t-test, ANOVA, and chi-square, and z-test, but we didn't really talk much about it. So t-test, chi-square would be the most common one. Number three, measuring relationship. That's when you look at correlation and you look at regression, in which you have dependent variable and independent variable. The last one is multivariate. We call multivariate because you have more than two. Multivariate data analysis, which consists of multiple linear regression, more than two independent variable, and multiple discriminant analysis, factor analysis, or a way to reduce the number of items in your construct, and then cluster analysis, and also perceptual mapping. So all of these data analysis techniques introduced in this chapter are as relevant for quantitatively analyzing customer data held within organization as they are for analyzing data from external secondary research or primary research sources. Okay. As you can see, all these techniques are now available on SPSS. So SPSS can actually do the job for all those statistical techniques that we just mentioned in this chapter or in this seminar. Okay, so this chapter has attempted to provide basic awareness and understanding. So more detailed discussion of statistical technique can also be found in the books when you read that in more detail, and also in additional reading from this textbook as well. Or you can also look at from the recommended textbook, which I have suggested to you at the beginning of the semester. Okay, so with that, I'm going to close this seminar. And if you have any question, yeah, feel free to email or make appointment. We can set up the Zoom link together. Otherwise, I will see you next time. I'll stop sharing and I'll stop